about reactions. Do you know about endothermic and exothermic reactions? First, remember the meaning of exo and endo. Exo means release and endo means absorb. And do you know about thermic? It means heat. So endothermic reactions are those which absorb heat and heat is released in exothermic reactions. Okay, can you give me an example of an exothermic reaction? Oh yes, you are right. Burning of matchstick gives out heat. It is an exothermic reaction. Now, can you give an example of an endothermic reaction? Wow, you are right again. Evaporation is happening as heat is being absorbed by water and molecules are getting away from each other. Look at this picture. This picture is a photosynthesis process in plants. Can you tell which reaction this is? You have understood it well. Photosynthesis is an endothermic process as plants take heat energy from sun and convert them into glucose with the help of water and carbon dioxide.
Have you ever wondered what can be considered as fuel? Why eating fats is helpful when you want to get through winter? And why thermite is good for welding? Well, we are here to help you figure that out. Thermochemistry is a branch of thermodynamics that deals with the study of the energy and heat affiliated with chemical and physical reactions. Enthalpy refers to the heat content of a substance. Calculating the enthalpy can be found by using the average bond energies, Hess's law, and the standard enthalpy of formation. There is also entropy. Entropy dictates the order and disorder of a substance. The entropy can tell which came first and last in a reaction. Calculating the entropy can be found by using the standard entropy of formation. Lastly, there is Gibbs free energy. This tells whether the reaction is spontaneous or non-spontaneous. This can be solved using this equation. Remember that T is in Kelvin. You can also use the standard Gibbs free energy of formation to solve it. Thermochemistry can be applied in so many ways, but we are here to talk about how it is applied in the industry. When driving a car, fuel is being used. In this situation, fuel is an exothermic reaction because it releases energy in the form of heat. Fuel is combusted. The enthalpy of combustion is an important criterion for a substance's suitability as a fuel. A workable fuel must also be easily ignited. And in the case of a fuel intended for self-powered vehicles, its energy in terms of mass and volume must be large. Hydrogen contains an extraordinary huge amount of energy. Therefore, hydrogen can power bigger objects like liquid propellant rockets and steamboats. Although, a hydrogen fuel cannot be used for cars as it is difficult to store in a high-pressure tank. Thermite doesn't explode, although it releases high heat. Therefore, it makes it an exothermic process. This heat is sufficient enough in welding and military uses, like burning certain equipment and thermite hand grenades. A iron-thermite reaction is initiated by heat. So, when the aluminum and iron oxides are mixed and heat is applied, a spontaneous reaction occurs. The reaction generates oxygen and therefore combustion occurs even in the absence of oxygen. Thermochemistry is actually found everywhere and anywhere you go. These inventors have used thermochemistry in a way that they are trying their best to make our lives better. We can conveniently extract metal and cut this and also properly use the right fuel in our vehicles so that we can take precaution. Thank you! We hope you enjoyed this video.
Created using Powtoon.
Thermochemistry. Water equivalent of calorimeter. Materials required. We require a wooden box with lid, calorimeter, thermometer, measuring jar, 250 milliliters beakers, distilled water, stirrer, and hot plate. Procedure. Measure 50 milliliters of distilled water in the measuring jar. Transfer it into the calorie meter. Using the thermometer, measure the temperature of water in the calorie meter. Let it be T1 degree Celsius. Remove the thermometer. Place the calorie meter in the wooden box and insert a stirrer in the calorie meter. The space between the calorie meter and the wooden box is filled with cotton to avoid heat loss. Take another 50 milliliters of distilled water in the measuring jar and transfer it into a 250 milliliters beaker. Heat water in the beaker to a temperature 10 to 20 degrees Celsius, higher than that of room temperature, and note the temperature of this warm water. Let it be T2 degrees Celsius. Add the warm water into the calorie meter without any loss of time. Immediately close the wooden box and quickly insert the thermometer into the calorie meter. Stir the water using the stirrer and continue stirring until the temperature becomes constant. Note down the temperature. Let it be T3 degrees Celsius. Record the observations. Calculate the water equivalent of calorie meter. Enthalpy of dissolution of ammonium chloride. Materials required. We require a wooden box with lid, calorie meter, thermometer, measuring jar, 5 grams ammonium chloride, distilled water and a stirrer. Procedure. Measure 50 milliliters of distilled water in the measuring jar. Transfer it into the calorie meter. Using the thermometer, measure the temperature of water in the calorie meter. Let it be T1 degrees Celsius. Remove the thermometer. Place the calorie meter in the wooden box and insert a stirrer in the calorie meter. The space between the calorie meter and the wooden box is filled with cotton to avoid heat loss. Transfer ammonium chloride into the calorie meter. Immediately close the wooden box and quickly insert the thermometer into the calorie meter. Stir the water using the stirrer and continue stirring until the temperature becomes constant. Note down the thermometer reading. Let it be T2 degrees Celsius. Record the observations. Calculate the enthalpy of dissolution of ammonium chloride. The enthalpy of dissolution of ammonium chloride is 13.73 kilojoules per mole.